All right, so today we're going to talk about LLM inference providers, and those mostly being the options you really have to how to run LLMs locally. I'm not going to go into any of the cloud ones, mostly because they're just self-explanatory, and plus I really think you could get a much better deep dive from those providers. And fundamentally, like, if you're going to go call OpenAI, Anthropic, or any of those guys, they figured a lot of this stuff out that I'm about to show you. So first of all, let's just walk through what those providers are. So I'm really going to go through like the ones you have locally, like Ollama and Llama.cpp, the HuggingFace Transformers, vLLM, and then at the end, actually give you a comparison, like at a glance, and some key takeaways when you actually look at them all. So the first one I actually put down was Ollama and Llama.cpp. You do see the slash as Ollama is just a wrapper of Llama.cpp. They just make it easier to download models. And mostly what they're really focused on is that they're really focused on just running things locally, with ease. They really focus on this GGUF format there, and I'm going to get into in a bit what that really is. And it's great for a quick demo. But again, because it's around that GGUF format, which is really designed to be a binary format that's easy for CPUs to run them, which is the other reason why a lot of accelerators have really picked up on them, mostly being that they're really easy to pop right into like an M1 chip. You also see like AMD, for example, has some products where they have the CPU and the GPU together. So that's why you kind of see that format take off. It's just easy to run these two things. But of course, the first problem you're going to run into is outside their immediate use case of just I'm chatting to this model, they really do not have any batch sort of processing. So if you want to just take, a big PDF, you want to send every one of those pages to Ollama, you're going to run into a whole lot of problems. And really the second one is that it's opaque in memory usage, which means, and I encourage you to try this if you have a GPU. Go to your Ollama, and then you can type in Ollama PS. That's going to tell you where the models are and they're loaded, which is going to tell you how much on GPU and CPU. As you increase the max sequence length, you're going to see it's going to make decisions on how to move the model between the CPU and the GPU, which is not ideal. And in fact, it can be very subtle that you're going to suddenly find, I have a GPU, why does I have my model on the CPU when I'm not expecting to hit crazy tokens, which again, not ideal. That you should not be the case. You should be able just to tell Ollama of, hey, I want you to keep this on CPU, I want you to keep it on GPU, but that is not what they're about. So again, you could try opening a ticket, probably they're not going to actually address it. And finally, not tuned for production, again, for the reasons I said. Now, there are things that you can do in there, like you can set how many models can run at a time, how many requests can that model serve. On the surface, they look great. They're not batching, though. If you actually look at serving one model and having concurrent requests, it tries to spin up like their own token limit, so you can quickly just run out of memory real fast on a MacBook. So let's go to the next one, which is HuggingFace Transformers. This one's made by HuggingFace, and it's a really amazing inference stack in that you have all the fine-grained controls you would like out of HuggingFace Transformers. You can tell which layer goes on which device, which accelerator gets used by which layer. They really do let you go layer by layer and decide where on the GPU will this be. You can also partially shard layers too. You can say half of your layer will be on one GPU and the other half will be on another. And that's great for that. It's also very featured. So anytime there's some new development, HuggingFace is the first to actually have it. For example, flash attention, that's not really something Ollama has. I know they've recently pushed it for just GPD-OSS, but again, flash attention's been out since 2023. How come none of the models have it on Ollama? Versus, this is really trivial easy to set up on HuggingFace. I'm going to just skip how to install flash attention, but all you need to do is just tell your Transformers model, I want to use flash attention, and the rest will just work just fine. So to give you an idea, running Quen 2.5 VL, the 7 billion, with Ollama through 20 pages of images for OCR Took me about 35 minutes on the 3090. This took like 8 minutes with Transformers. Even though I had a much more aggressive quantization on Transformers, Transformers does have quantization. Some of those are actually better than the GGUFs. For example, AWQ is dynamic when it quantizes, so you will practically have full precision of your model during the quantization there. Now, some of the drawbacks is, of course, I mean, it's developer-centric. You're really going to have to know what you're doing with your model. If you really don't understand, like, what are some of those offloading or sharding parameters, you can move your model in weird ways that is going to slow down your run very significantly. There's also the other thing is there is a steep learning curve out the box. In fact, all of these models are actually not standard. That's something that Hugging Face has decided to do. It's the opposite of what, for example, other providers like, for example, PyTorch, they just want to standardize on one interface. Hugging Face just said, look, you could put up a model, we'll have a different backend, which really means every single model, like Gwen has its own architecture on there. Llama has its own architecture on there. BERT has its own architecture, and so on and so forth. There is no standard architecture on there. That's also another reason of why you see Hugging Face Transformers being ahead of the curve is day one they can just use a model where Ollama will need to go patch this. And really the disconnect we've seen there is you need to rewrite some chunks of Ollama to just use Gwen 3 Next or use Gwen 3 VL because they have the vision model as part of the MOE layers now. That's something that Hugging Face just already does. Now finally, like I said, manual memory management, it does require some understanding, but the flip side is there's a lot of developer tooling there.
That's just a laser pointer.
That
doesn't change yours. That changes mine.
Oh, right, all right. No, let's see, does this still
There
work?
you go.
Yeah, okay. Now, the other one I'm going to cover is vLLM. This is a very popular one for inference. Now, it is optimized for high throughput, and they have this concept called paged attention. All that means is, so typically right now, if you're going to run an attention mechanism, you know, the attention is just going to put everything onto one device, which means if your device gets overloaded, you're just going to crash in memory. Now, flash attention is trying to just control how the matrix of the attention model is being constructed. It does some smart things. But fundamentally what they now do is they can page the attention like memory, so you're not going to blow up. vLLM is fully production ready out the box, which actually takes us some of the drawbacks. It's really heavy to set this up, and you do need a bigger GPU to really make vLLM worth your while. Like if you have a smaller GPU, I would say under 12 gigs, I really don't think you're going to get much value out of vLLM. Like just the fact that like you're going to be stuck in the paging of your attention. That's not great. Where if you have, for example, like a 3090 or a 4090, or if you're going to get a 5090 in this day and age, those models can't. Those GPUs can actually take off the taps of vLLM at home. So if you do have a lot of processes where you're constantly running, you know, tons of inference to LLMs, it is actually worth checking out vLLM. Especially, for example, if you're saying, you know, I got to process PDFs, I want to do a bunch of RAG, and I want to go use Open Web UI while I'm doing this. And that's the thing that gets most people is you're like, hey, I'm going to go to Open Web UI, and I'm going to go do Ollama stuff. Well, you're talking the same Ollama, and either one of the processes is waiting, or you're seeing a lot of processes are created, there's a lot of memory use. And in fact, the problem is that your hardware can start throttling what you're doing, so all of a sudden you're thinking, oh, I'm running all this stuff on GPU or on the M1 chip. You might see that the M1 chip just says, look, dude, I am so overheated right now, I'm just going to wait for the request. Now again, NVIDIA GPUs have heat sinks, that's not really the case there. But again, this is something vLLM is designed to actually overcome and be an inference platform. But like I said, it is not easy to use, and you're going to be paying for it. So let's look at an overall comparison. So now you can see ease of use. Essentially, Ollama is the easiest to use, where vLLM is really hard. But performance, I mean, Ollama is not actually great, does not support batching. But again, it just needs a CPU. They don't make any sort of assumption about your hardware. Now, this one, again, the Hugging Face one, not as easy to use. Very great performance. You can practically get fantastic performance out of this. It does have batching. You can control how much batching you give to the model. You can easily batch multiple requests all at once to that model, and it handles it under the hood with PyTorch. It is production ready. You can use Hugging Face Transformers in production. I've certainly done that. And then again, I mean, the one GPU, you kind of need a GPU. You can, I want to say, use the Mac M1 chips and stuff like that, or whatever chip they're on now. You can definitely use them through Hugging Face. PyTorch is what it uses under the hood, but it can use other backends. Finally, vLLM is not easy to use whatsoever. In fact, I'll tell you, installing vLLM in and of itself is not easy. Just use the Docker if you want an easy to set up. And again, I mean, this could take hours to fiddle. You will get maximum performance out of vLLM. It has batching just out the box. And again, they really put batching as a first-class citizen. You walk through the the documentation they have, and they will kind of talk you through how do you batch the requests, how many tokens do you want to allocate per request. They really make that very seamless to do, just out the box. But you kind of need a higher end GPU for that, and like I said, you're not going to get much gain if you have a tiny GPU, and vLLM does not work with the MacBook. It's not designed to. They're designed for GPU clusters. So with that, essentially some key takeaways. Ollama and Llama.cpp are easy for local development if you just want to get going. Hugging Face Transformers, very flexible, very much on the cutting edge. Every model in Hugging Face that comes out, you can go use them. In fact, I'll tell you, Gwen 3 was available, the architecture, a couple days before the weights dropped. And that's something we see is that these frontier research labs do put out the architecture of the models on Hugging Face before the weights are even available, which means day one, the weights drop that hour, you can just go run the models. And you don't have to figure about, does the GGU have good and all this other stuff. It just works out the box. If you have a production use case, like, you got to go inference on a bunch of GPUs, well, vLLM is really your only game in town. I know there's SG Lang. I've conveniently just decided to ignore it for this talk. That is viable. And again, I mean, vLLM can use transformers under the hood as a backend. Not a bad option. But with that, I will open this up now to comments, questions, concerns, or anything else. Yeah.
Quick question. I know Ollama uses Llama.cpp, but Llama.cpp also has a serving capability. Try that?
Also, repeat the question, please.
Yeah, so the question was that Llama.cpp has serving capability. Have I tried that? I certainly have, and that's actually very true. I mean, Ollama is essentially just a wrapper around Llama.cpp. I certainly have, but I think at a fundamental level, I don't see how a lot of the, for example, the tricks that vLLM has, or really the stuff that Hugging Face Transformers, or how low level you can work with that memory. I just don't think that their architecture and what they've optimized for allows you to just have that level of batching. Because if they actually had more dynamic batching, that would mean that that's more CPU activity. I think that there's just design choices they've made, and that was not their primary goal. Yeah?
From a software engineering perspective, so if you're going to put vLLM on one machine and with a lot of GPUs, that's not going to be very cost effective. Which one of them are more distributed friendly?
I would say vLLM is distribution friendly. You can distribute over all the GPUs you have. Hugging Face Transformers can do the same. And if you actually look through their documentation, they do have a lot of documentation on how you can move the same model to multiple. But just remember, yeah, I would say vLLM is user friendly if you can install it. The reason I say it's not easy to install is just because of Oh, distributed friendly? Yeah. Yeah, vLLM can be distributed friendly if you want to distribute the same model and just have copies of it across. If you want to have one model that's sharded, you can do that with vLLM. As like I said, it does use transformers under the hood. Transformers will easily let you distribute a lot of those models. And they have documentation on how you can do that. Unfortunately, you do have to actually know something about the model, but because of the higher level interface transformers gives you, you can actually introspect the models themselves. They have this layer object that you can just check the layers. It's very doable. So while you do need to know something about the model, you don't need to know everything about that model. Yeah.
So a lot of the new, I guess, best frontier models are mixture expert models.
Mm-hmm.
And so I'd like to know if you looked at how each of these handle that. Because for me, I've got a 4090
Mm-hmm.
gig. It's been great for those small models like 2232B, but then now suddenly they come up with these great mixture expert models that use a lot more, tokens, but the aggregate tokens is smaller, yet it doesn't fit on the GPU.
Mm-hmm.
So, yeah, I'm kind of curious, have people gotten that to work on things like local GPUs and which one of these systems, if any, works for that?
Mm-hmm. Yeah, so I think the question essentially is, let me make sure I understand it. So what you're saying is that, well, most of these mixture of experts models, they really have a much fewer activated parameters. So can they move some of that off and put those on? There have been some efforts to do that. I think the biggest challenge, though, is the fact that, if you are to look at which experts do I want to put on, you have a lot of activity at the CUDA layer, which means you're having to move data between CPU and GPU. So in theory, Llama.cpp could do it more efficiently, but then again, there's the whole problem then of how are you going to move those layers, and if you don't know that much about the model, and that's the problem with the GGF format. They don't want to know about what hardware you're running. But the problem is that if you know that it's on CUDA, you can make so many optimizations for that. I would say that that's probably an area that NVIDIA is most active in, is trying to figure out, how can they do it at the driver level and make it just map memories that are easy to swap. AMD has done a lot of work on that because they have the CPU and the GPU, and they're trying to have this hybrid architecture that they're there for. Unfortunately, MOEs are just way too new. I mean, they've really been only out for a couple of months, versus dense models have been there for years on end, which is kind of why you've seen that the quantization behind GGUF has gotten better and better now at this point, because, I mean, it is effectively almost a 2-year-old format now at this point. I mean, I know stuff is brand new. It is 2 years old now, where a mixture of experts have really only just come about. So that's kind of what you're seeing there. There's not a whole lot of mature support.
Unified memory, you have a better answer for it, but I'm asking for the answer for the...
Yeah, I mean, in theory they do because of that. In reality, memory management and all that stuff, that's where it's going to come in at the developer level. Yeah. How much VRAM? It really depends on the LLM. Do you have any in mind?
For example, I have access to my tank, which is 4 gigabytes.
Uh-huh.
Two of them, so I try to put up, together.
Yeah, so I think with those two, you could probably just run a 70 billion. You just distribute that across the two. You might be able to get away with running the biggest Gwen 3 MOE at 225 billion parameters. You're probably going to need quantization, though. Again, those are all doable. So you could definitely run with any of these frameworks on them. Again, I don't really know how well does Ollama or Llama.cpp distribute across multiple machines. That's really where vLLM and HuggingFace really let you just take care of that in ways that that are just designed for you to just saying, I want to put these layers here, I want to put those layers over there.
Awesome. Awesome. Well, thank you so much.